All right, students, let's continue with some balancing practice. This is going to go over questions 6 through 10 in your notes. Hopefully you've had a chance to try these out on your own first, and that you are just using this to check your work. All right, so we have dicarbon hexahydride. So we have to write our skeletal reaction first. So dicarbon means it's C2H6 plus oxygen gas. Remember, oxygen is diatomic, so we have to put that subscript of 2 to produce carbon dioxide and water, H2O. All right, so I will say the combustion reactions are the hardest ones to balance. Okay, so we're going to split this into our reactant side and our product side, and we're going to count carbon, hydrogen, and oxygen. Carbon, hydrogen, and oxygen. So over on the reactant side, I have 2 carbon, I have 6 hydrogen, and I have 2 oxygen. On the product side, I have 1 carbon, I have 2 hydrogens, and I have 3 oxygens because I have oxygen here on the carbon dioxide and oxygen with the water. So let's go ahead and balance the carbon first. So in order to balance the carbon, I've got 2 on the reactant side and 1 on the product side. So I have to put a 2 here. That changes my carbons to 2, but it changes my oxygens to 5. 2 times 2 plus 1 over here. Okay. Now the oxygens we're going to save for last because oxygen appears in both places on the product side. So remember, if it appears in more than one place, we save that for the end. So here's what happens when we take and balance our hydrogens. I have 6 hydrogens on the reactant side, and so far I only have 2 on the product side. So in order to balance the hydrogens, I have to put a 3 here. So I've got 6 hydrogens. Changes my oxygens though now to 2 times 2 is 4 plus 3. So I've got 7 oxygens now. So my carbons are balanced. My hydrogens are balanced. My oxygens are not. And this is the point where a lot of students get stuck because they have 2 oxygens on the reactant side and 7 on the product side. So one of my tips was, if you get stuck, double your coefficients. So I'm going to double this carbon dioxide to 4, and I'm going to double my hydrogen to 6. So I got to recount my product side. I've got 4 carbons. I have 12 hydrogens, and I've got 14 oxygens. Remember, I have oxygens in 2 places. 4 times 2 is 8 plus 6 is 14. I've got to rebalance, unfortunately, and this happens where you have to just keep rebalancing things. I have to rebalance my carbons and hydrogens. I have to put a 2 here so that I can get up to 4 carbons and 12 hydrogens. In order to balance my oxygens now, I have 2 on the reactant side. I have 14 on the product side, so I can just put a 7 here, and now I'm up to 14 oxygens, and I'm already balanced. Okay. Oh, this one. So for this one, we have to write chemical formulas. We're going to have to remember how to write ionic compounds and drop and swap. So if you're given words and you have to write the formulas, if you're still a little unsure from the ionic unit and how to write compounds, write your ions first. So aluminum, look at your periodic table. Aluminum has a +3 charge. Sulfate, the 8 means that it's a polyatomic ion. You're going to look at your polyatomic ion list, and sulfate is SO4 2-. So aluminum sulfate is Al2 SO4 3. Plus, let's do the same thing. Calcium, look on your periodic table. Calcium is Ca +2 because it's in group 2. Hydroxide is a polyatomic ion. It's on the list. It is OH -1. So the formula for calcium hydroxide is going to be Ca. The OH has to be in parentheses because remember, if we're going to have more than one, we have to put that in parentheses. Yields aluminum hydroxide. So remember, aluminum is going to be +3 because it's in group 13. Hydroxide is OH -1. So aluminum hydroxide is going to be AlOH3. And calcium sulfate, calcium, remember, +2 charge from the periodic table. Sulfate on the polyatomic ion list. We already wrote it on the reactant side, SO4. So calcium sulfate, those 2's are going to cancel out with CaSO4. So one of my tips was to count the polyatomic ion as a unit if it stays intact on both sides of the reaction. So you can see that the sulfate stays together, and we can see that the hydroxide stays together. So we can count that as a unit. So instead of counting oxygens and hydrogens and sulfurs all separately, because oxygen's in everything, it'll be really hard to count. So I've got aluminum, I have sulfate, I have calcium, and I have hydroxide. Same thing over here. I've got aluminum, sulfate, calcium, and hydroxide. So on the reactant side, I've got 2 aluminums. I have 3 sulfates because of this 3 back here. I have 1 calcium, and I have 2 hydroxides because of this 2 back here. On the product side, I've got 1 aluminum. I have 1 sulfate, because remember, sulfate is SO4. This 4 doesn't mean I have 4 sulfates. I have 4 oxygens, and that's part of the sulfate ion. Okay, I've got 1 calcium, and I have 3 hydroxides. So we can balance our polyatomic or our metals and nonmetals first. So I have 2 aluminums. I've got to get 2 aluminums on this side, so I'm going to put a 2 here. That gives me 2 aluminums. How many hydroxides do I have? I've got 6 hydroxides. I'm going to go ahead and balance those calciums. Oh, my calcium's already balanced, excuse me. I got to balance my sulfates. So I have 3 sulfates on the reactant side. I need 3 sulfates on my product side. So I'm going to put a 3 here in front of my calcium sulfate. That changes to 3 sulfates, 3 calciums. So now I can balance my calciums. I have 1 calcium on the reactant side. I have 3 calciums now on the product side. So I need to put a coefficient of a 3 here in front of the calcium hydroxide. Now I've got 3 calciums, and I've got 3 times 2 or 6 hydroxides. Remember, go back to your reaction and check and make sure you have enough. So I've got 2 aluminums, and I have 2 aluminums. I have 3 sulfate groups. I have 3 sulfate groups. I have 3 calciums, and I've got 3 calciums. I have 6 hydroxides. I have 6 hydroxides. Let's not write that stuff though. So this reaction is balanced. Okay. I gotta erase my work here. All right, so let's take a look at this next one. I'm going to separate my reactant side from my product side. I'm going to list my elements, phosphorus and oxygen. Over here on the reactant side, I have 4 phosphorus and I have 2 oxygen. On the product side, I have 2 phosphorus and I have 5 oxygen. So in order to balance this, I need to balance my phosphorus. I need to get the product side up to 4. So what coefficient am I going to have to put here to do that? I have to put a 2 in front of the P2O5. Changes my phosphorus to 4, and it changes my oxygen to 10. So now my oxygens aren't balanced. I only have 2 on the reactant side, but I need 10. So what coefficient is going to go here in front of the oxygen? A 5, because 5 times 2 is 10. And let's check our work. I've got 4 phosphorus. I have 4 phosphorus. I have 10 oxygens. I have 2 times 5, 10 oxygens. So this one is balanced. Let's look at number 9. Separate the reactant side from the product side. List your elements, silver and sulfur. Silver and sulfur. I have 1 silver. I have 8 sulfurs. I have 2 silvers. I have 1 sulfur. So you can start by balancing your silvers. Or what I'm going to do is I'm going to put a coefficient in front of the Ag2S first, because I realize that any coefficient here is going to change something over here. Typically, if I see an element by itself, I'm going to balance that towards the end. I'm going to balance the ones that are in compounds together first. So I've got 8 sulfurs. I need to get 8 sulfurs on the product side, so I'm going to put an 8 here. So that changes my sulfurs to 8. But now I've got how many silvers? 16. So in order to get 16 on this side, I just had to put a 16 as a coefficient. What happens if you balance the silvers first? Doesn't matter. Okay, you're still going to end up with the same answer. Let me go back here. If I balance the silvers first, I put a 2 here. That changes my silvers to 2. My sulfurs aren't balanced. I still have to put that 8 here, changes my sulfurs to 16. Sorry, not my sulfurs. My sulfurs to 8. Changes my silvers to 16. So I still have to come back over here and fix my silvers by putting a 16. So I just have to do an extra step in changing that silver again, but I still arrive at that same answer. So let's take a look at this last example, 10. I have aluminum, that's just aluminum, plus bromine. Remember, bromine is diatomic, so that's going to be Br2. Combined to form, so that's my arrow, aluminum bromide. This is an ionic compound because it's aluminum, metal, and a nonmetal. Aluminum has a charge of +3. Bromine has a charge of -1. So that's Al Br3. So I list out my elements separately. Aluminum and bromine, 1 and 2. Aluminum and bromine, 1 and 3. So my aluminums right now are balanced. I just have to get my bromines balanced. So I've got 2 on the reactant side, 3 on the product side. I have to get both of those up to 6. So I've got to put a 3 here in front of the Br2 to get my Brs up to 6. I have to put a 2 on this side in front of the AlBr3 in order to get 6 bromines. And how many aluminums do I have now? I have 2. So in order to balance my aluminums, I have to put a 2 here in front of this one. And now it looks balanced. Go back to the original reaction to check your work. Don't look in your workspace. I've got 2 aluminums. I have 2 aluminums. I have 6 bromines, and I have 6 bromines. So I'm balanced. That's it for balancing. It's really all about practice. The more that you do, the better you're going to become. So I encourage you to do as much practice as you need to do in order to become efficient at balancing. And if you have any questions, don't ever hesitate to reach out and get some help. Okay, I'll talk to you later.